Hello students. So today we are going to learn about domain, codomain and range of a relation. So in the last class we have already seen what are the ordered pairs, what is the Cartesian product of two sets, and what is the relation. We have already seen from the example also, and we have seen the definition also. In this class we are going to learn about the domain, range and codomain of a relation. So definition of domain: the set of all first elements of the ordered pairs. The set of all first elements of the ordered pairs in a relation R from a set A to a set B is called the domain of the relation R. Okay. So what is domain? The definition of domain is the set of all first elements of the ordered pairs in a relation R from a set A to a set B is called the domain of the relation R. Now we'll come to the range. The set of all second elements in a relation R from a set A to a set B is called the range of the relation R. So what is range? The set of all second elements in a relation R from a set A to a set B is called the range of the relation R. Now come to the third, that is codomain. What is codomain? The whole set of B. The whole set of B is called the codomain of the relation R. Now we are going to understand it from a simple example. So in the last class also we have seen what is a relation, what is the definition of a relation, but just we are going to revise it so that it will be helpful in understanding the concept of domain, range and codomain of a relation. So what is relation? A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. Okay. A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. The set is derived by describing a relationship between the first element and the second element of the ordered pairs. So what is a relation? The subset. It is a subset of the Cartesian product of two sets. What is a relation? Relation is a subset of the Cartesian product of two sets. The subset is derived by describing a relationship between the first element and the second element of the ordered pairs in A cross B. The second element is called the image of the first element. The second element is called the image of the first element, and the first element is called the pre-image of the second element. Second element is called the image of the first element. We'll learn it from one example. If there is an ordered pair 3, 5, this is an ordered pair. So this is the first element, this is the second element. This is the first element and this is the second element. So 3 is the pre-image of 5, and 5 is the image of 3. Okay. The second element is called the image of the first. So 5 is the image of 3, and the first element is called the pre-image of the second element. So there is one example. It is a relation. Okay, so there are two sets, set A and set B. Set A is having two elements, A and B. Set B is having 4 elements, Ali, Babu, Bindu, Clara. So we can find the Cartesian product of this. two sets A cross B. Correct? So because that is called, so if the number of elements in set A is how many? 2. Number of elements in set B is how many? 4. So total number of elements in the Cartesian product of from A to B, the Cartesian product of two sets from A to B, there will be 2 into 4, that is 8 elements. Correct? So there will be 8 elements. So as we have already learned that relation is a subset of this set. Correct? Relation is a subset of this set. Relation is a subset of this set. Correct? Relation is a subset of A cross B set. Means there may be we can form a relation by taking one element from A, one element from B. We can form a relation by taking one element from A, two elements from B, from two elements of A, and from three elements of B, like that. So if the number of elements in Cartesian product of A and B is 8, then total number of relations, how many total number of relations can be? So total number of relations can be, we have already seen it, number of relations, total number of relations can be 2 to the power 8. Okay? Because if n A is equal to P, means number of elements in set A is equal to P, number of elements in set B is equal to Q, then number of elements in Cartesian product of set F from A to B will be P into Q. And the total number of relations will be 2 to the power PQ. Correct? So this is one of the one of the subset of the Cartesian product A cross B. Correct? So here, how many ordered pairs are there in this relation? There are 3 ordered pairs. There are 3 ordered pairs in this relation R. And how we have defined this relation? If A is the first letter of the name of the persons and B is the name of the persons, then A is related to Ali because the first letter of Ali is A. B is related to Babu because first letter of Babu is B, and B is also related to Bindu because the first letter of Bindu is B. Okay? And the Clara is not related to anybody. Means there can be so many relations. How many relations can be there? 2 to the power 8 relations. So this is one of the relation which is having 3 ordered pairs. A Ali means A is related to Ali, B is related to Babu, B is related to Bindu. It means A is the first element, Ali is the second element of the first ordered pair, B is the first element, Babu is the second element of the second ordered pairs, and here B is the first element and Bindu is the second element of the third ordered pair. Correct? So here, as per the definition, what is the, just a minute. So as per the definition, what is the domain of this relation? Domain of this relation. So domain of this relation will be the number of the elements of set A. The elements of set A means the number, the elements of the first set are the domain. So we'll write it here. Just I'm making some space for writing. Okay, so domain will be domain of this relation. Domain of R means this R will be A and B, because here B is repeated, so we'll not write it 2 times. We'll write only 1 time. Then range of R. Range of R means, see here, the second element of the set. The second element of set are Ali, Babu, and Bindu. So Ali, Babu, and Bindu. These are the range of R. And codomain means all the elements of set B. All the elements of set B. Whether they have taken part in the relation or not, we have to take all. So codomain of R will be Ali, Babu, Bindu, and Clara. All. Correct? So as per the definition of domain, range, and codomain, we have already find the domain, range, and codomain of this relation. See here, what is the domain? The set of all first elements of the ordered pairs in a relation R from a set A to a set B is called the domain of the relation R. What is the range? The set of all second elements in a relation R from a set A to a set B is called the range of the relation R. What is codomain? The whole set of B, the whole set B is called the codomain of relation R. Now we'll see it from one example. Now what we find here, some important points are here. Range is a subset of codomain. Range is a subset of codomain because codomain means all the elements of set B. And range 100% it will be a subset of codomain. A relation may be represented algebraically either by roster method or by set builder method. An arrow diagram is a visual representation of a relation. In the previous one, we have already seen. So that is a visual representation of a relation. And if number of elements in set A is equal to P and number of elements in set B is equal to Q, then number of elements in the set of Cartesian product of A and B will be P into Q. And the total number of relations from A to B is 2 to the power PQ. Correct? 2 to the power PQ. A relation R from A to A is also stated as a relation on A. Okay, so it is not necessary that you have to always take the relation from two different sets. No, we can define a relation between two same sets also, means A cross A. We can also define A cross A. Correct? So a relation R from A to A is also stated as a relation on A. So this will be called the relation on A. Now there is example. See, let A is equal to 1, 2, 3, 4, 5. Define a relation R from A to A by R is equal to xy such that y equal to x plus 2. R is a relation where x is the element of set A, y is the elements of set B, and there is a relation from A to B like this, y is equal to x plus 2. It means if you can take x as 1 to 5. You can take x as 1 to 5. You can then, if you are taking x is equal to 1, then y will become what? 1 plus 2 is equal to 3. So 1 is related to 3. If you are taking x is equal to 2, then y is equal to 2 plus 2, 4. So 2 is related to 4. If you are taking x is equal to 3, then y will become y is equal to 3 plus 2, 5. So 3 is related to 5. Now you cannot take x is equal to 4, because if you will take x is equal to 4, then y will become 4 plus 2, 6. So 6 is not a part of A. Only 1, 2, 3, 4, 5 are the elements of set A. So here our the relation ends. Means the first order pair of this relation is 1, 3. Second ordered pair of this relation is 2, 4. Third ordered pair of this relation is 3, 5. Correct? So as per the definition, what is the domain of this relation R? So this in this relation there are 3 ordered pairs. So first element of this relation, what are the first elements? 1, 2, 3. 1, 2, 3. Correct? So 1, 2, 3 are the domain of R. And then range of R. Range of R means, see here, the second element. 3, 4, 5. Second element of the relation are called range. So 3, 4, 5 are a range. Now, what is the codomain of R? Codomain of R means all the elements of the second set. All the elements of the second set, whether they have taken part in the relation or not, we have to take all. So here the codomain of R is equal to 1, 2, 3, 4, 5. Okay. So now I hope the idea of domain, codomain, and range will be clear. We'll see one more example. See here, there is a question. Let A is equal to 1, 2. Set A is equal to 1, 2. B is equal to ABC. Find the number of relations from A to B. So we have already seen that. What is the number of elements in set A? 2. What is the number of elements in set B? Is equal to 3. Then what is the number of elements in this set? Means in Cartesian product of set A with B, 2 into 3, that is 6. Then we have already seen that formula, the total number of relations is equal to what? 2 to the power 6. Correct? So here the same thing here again. The Cartesian product of A and B, there will be how many ordered pairs? There will be 6 ordered pairs. See here. 1A, 1B, 1C, and then 1, then 2A, 2B, and 2C. Correct? 1A, 1B, 1C, 2A, 2B, 2C. Okay. So there are 6 elements, 6 ordered pairs in the Cartesian product of A with B. Since number of elements in Cartesian product of A and B in this subset, in this set is how many? 6. So therefore, the number of relations from A to B will be 2 to the power 6. 2 to the power 6 means 64. Correct? So in this way, I think in this class, the idea of domain, codomain, range, and the total number of elements in a in Cartesian product of 2 sets, and also how many relations can be formed from the Cartesian product of A cross B. It is clear. I think it will be clear to you. Correct. So in next class, we'll see the next topic, that is called function. Now we'll come to functions. Means all functions are relations, but all relations are not functions. So why this is the difference, that we are going to see in the next class. Okay. So we'll meet in the next class. Till then, have a nice time. Bye-bye.